Good evening, everyone, and welcome to our today's session. So
Good
let
evening,
people
sir.
join. Good evening. So let people join, and we will shortly start our introduction. Okay. So I hope my screen is visible and I'm audible live and clear.
Yes, sir. Audible.
Okay. Thank you. So welcome everyone again to our week 10 live session of NPTEL course on non-conventional energy sources. So this course is taken by Professor Prathap Haridoss from IIT Madras, and today we will be having the 10th interaction session and one-to-one live session on this course. So again, as my introduction, I am Lalit Bharti, Prime Minister Research Fellow in the Department of Physics at IIT Kharagpur. These are my contact as email address and my LinkedIn profile. So you are always free to contact me over my email or connect me through LinkedIn. So this is our week 10 discussion, and the course contents are mainly different type of batteries, their types, mainly lithium ion battery, and we will be discussing few questions of previous week of week 9. So let us start with our assignments questions. Okay. So this is our question 1. This is based on the electrochemical series. So let me start with the importance of electrochemical series. So whenever we study any kind of batteries or we use any kind of batteries, so these electrochemical series is very important because it defines their particular voltages uh, with comparison to their reference electrodes or whatever reference we have taken. So the electrochemical series is very important in that case. So let us take the question, and meanwhile I will describe the importance of electrochemical series further. So the question is, in the standard electrochemical series, the potential corresponding to hydrogen electrode is set to zero variable arbitrarily. So this statement is actually true. So we always take why it's true, because we always take this H plus slash H2 as our reference, or we take this as zero because we need a reference, and hydrogen is taken as the reference, or standard hydrogen electrode is taken as reference for all of the uh, possible electrodes based made up of any metal or any composite. So if you're taking lithium as your targeted uh, electrode, so if you're talking about lithium plus, so your voltage will be minus 3.05 with reference to hydrogen. So you need to keep in mind that it is based on it is related in with the comparison to H2, not your sorry. Okay, I couldn't see the pointers. So okay, let it be. Okay, so if you ask me that the lithium ion, if you take a lithium ion battery, so voltage would be around 3.7 volts. But here you consider it, keep it in mind that your it is with the comparison to your H2. So what is a electrochemical series basically? So it is list of metals in order of decreasing, or let's say increasing reactivity or ease of oxidation. So ease of oxidation means if you go up, your tendency for oxidation will increase, and as you go down, your tendency for reduction will increase. So that is why it is given the E naught is minus in negative, and it is highest for lithium. That is why lithium ion batteries are very much uh, interesting in all type of batteries, and these are widely used because the lithium to lithium plus oxidation is very easy, but the voltage is very high, and it gives a very high voltage when you make a kind of make a battery of lithium ion based or lithium ion uh, mechanism. You use any mechanism. So that is why lithium ion batteries are worldwide used. Then if you go down, you see aluminum is there, iron is there, so you can make a battery of any of the material metal, but lithium has the highest tendency of oxidation. That's why you get a very high voltage. So the higher metal in the series, such as alkaline metals and alkaline earth metals, are more reactive or more easily oxidized than the lower metals in the series. So that is why you see you cannot take the lithium in normal air, because it will, if you take a foil of lithium in normal air, it will directly interact with the air and the moisture, and it will directly give you an explosive reaction. So that is why lithium and sodium, this kind of metals, these are kept in a uh, glove box where the environment is either inert or filled with a particular gas. So they will not interact, and the hydrogen, the H2O levels are minimized to a very very low number. Let's say less than 0.5 ppm. Ppm is parts per million. Similar case with magnesium. Magnesium, you always you don't. Magnesium is also quite reactive. Aluminum is also reactive. You always see aluminum is have the tendency to make a layer of aluminum oxide. So if you have a aluminum foil, you don't see, if you touch it, you don't touch the bare aluminum. You always touch the film of aluminum oxide. And similar to other cases like iron. So iron is also having tendency to make iron oxide, but it's still, it is lower, but it has the tendency. So the higher the higher order in this series, the more oxidation. So what is oxidation? Basically, if you have a particular oxidation state, and if it is increasing, then it is called the oxidation, and in that case it will emit the electron. So if you have a plus, and if it is making a plus 2, and with, obviously we need to balance the electron, so the charge should be balanced. So here we have a extra electron. So if it is emitting extra electron, then it's oxidation. If it is accepting electron, and if the reaction is going in the opposite direction, means a 2 plus is going to produce a plus, then it is reduction. So oxidation, reduction, keep it in mind. So if lithium is going to lithium plus, that is oxidation, and if lithium plus is going to lithium back, it is reduction. So the same thing happens in a battery. Your These reactions occurs in each cycle. So one will be one lithium will be going through oxidation, will make lithium plus, and then in reverse, while charging, it will make the lithium full, the Li from the Li plus. So this is a very basic question, but the electrochemical series is quite important to understand, to remember. Then we have the second question. It is again based on the electrochemical series. So it says the batteries that have the same voltage use same reactant internally. So they are asking if you have two batteries, let's say lithium and magnesium. So this is, one is lithium ion battery, another one is, let's say, sodium or magnesium ion battery. So will the voltage same? So the answer is clearly no, because they have different positions in the electrochemical series, and they have the different E naught values. Means there, while oxidation of lithium to lithium plus, it will produce a voltage of 3.05 negative with reference to the hydrogen electrode, and magnesium will produce only minus 2.37. So clearly, if you choose different type of metals, your voltages or the open circuit voltage will be different for this kind of systems. So that is why lithium is also considered, and lithium ion batteries are more used, because their OCVs are high, or their voltages are high compared to all other standard metal ion batteries. So that is done. Then you have third question. It says electrolytes must have good electronic conductivity in order to complete the circuit and enable the battery to function. So let us understand what is separator and what is use of separator. So this is a typical battery. This is your cathode or your positive side. This is your anode or negative side. And you have some material at the cathode side and you have some material at the anode side. And then you have a separator is a kind of film which avoids the short circuit. So it will keep cathode and anode separated while your electrolyte will be filled. So ions can move. So electrolyte is made up of lithium salt. So your lithium ions can move through the separator, but electrons cannot move. And these these materials or the cathode anodes cannot touch each other, because if they touch each other directly, whatever voltage is generated, they will directly short circuited, and the overall voltage will be zero. So we don't want to get them short circuited, and as well as we don't want to make the flow of electrons through because if the flow of electron is directly happening here, then they will be self discharged. So what is the criteria? So we will use a separator which is permeable to electrolyte. Electrolyte is basically non-conductive for electrons, but highly conductive for the ions present. So these the lithium ions present. So the question says electrolyte must have good electronic conductivity. So, but not that is false, because electrolyte should have good ionic conductivity, very high ionic conductivity to conduct the lithium ions throughout the separator, but the electronic conductivity should be very low. So these are the 3 points. Separator should avoid short circuiting, should conduct the lithium ions or whatever ions, and should not conduct electricity. Electricity means the flow of electrons should be restricted. So this is about this electrolyte and the separator. So this question is again done. So this statement is false, that we don't need good electronic conductivity, but we need good ionic conductivity for electrolytes. Then we have the fourth question. Just wait a minute. Okay. So the next question is on the C rate. Let me just share the link to YouTube. Okay, so it is on the C rate. So the question is, charging at 6C rate means a fully discharged battery will be charged in how many minutes? So we need to understand what is C rate. So basically your C rate means your 1C is your battery should be charged in 1 hour. So whatever capacity you have of the battery, if you are charging your battery in 1 hour, then your charging rate is 1C. So it is irrelevant to what is the capacity. So let's say you have a 100 mAh battery or 1000 mAh battery. If you are charging this at your C rate, so your current density will be different for both of them, but they should be charged in 1 hour. So 1C is equal to battery should be fully charged in 1 hour is equal to 60 minutes. So if you are going to higher C, means 2C, 3C, 4C, means 2C means you are charging your battery in 1/2 hour or 30 minutes. So in case of 3C, 1/3 means 20 minutes. And if you are charging in C/2, C/3 means you're charging slower and you are taking more time in the in charging the battery. So what is the importance of the C rates and the charging rates? So it is evident that if you charge your battery slower, so why the, let's say for example, let's take example of your mobile phones. So why they give you why the suggestion is given to charge your battery with slower rates? Because if you charge your battery with slower rates, your ions will get sufficient time to intercalate in your cathode as well as in your anode. So whatever reactions are happening, so you will, that battery will have enough time to complete those reactions, and your capacities will be higher, as well as your life of the battery will also be higher. And in opposite, if you're charging your battery very fast, so the ions will not get sufficient time, so they will get charged, but their efficiencies will be decreased, and your lifetime also will decrease. So if you see in real life, if you use fast chargers in your mobile phones, your battery will be charged very fast, but their life will decrease, and their efficiencies means their capacities are also decreasing by each cycle. So keep it in mind, you should charge your batteries every time as slow as possible, whatever or time you have, but you should charge your battery as slow as possible to maintain its life and its capacity. So back to our question. So if you have the rate of 6C, 6C means you are charging in 1/6 hour, means in minutes, 60/6 is equal to 10 minutes. So this formula you need to use, and whatever question is asked, you can just convert your C rates in your minutes. Then you have the fifth question. It says batteries help in moderating the difference between demand and supply across the day by storing and releasing the energy as required. So that is true. So what is the main use of batteries? So this is for the stationary batteries. So if you have high demand but no supply, in case in even in opposite case, we have high supply but no demand. So let's take an example of solar cells. So in daytime, you have a lot of energy. Let's say you are producing 1 kilowatt of power. So this is your peak power generation, but your demand is not enough, not 1 kilowatt. Your demand is only 0.5 kilowatts. So in that time, you can store your additional energy in batteries, and when in night, or let's say in a weather where your energy production is very low, or let's say in night you have no energy production, or you have 0 kilowatt of energy production. So what will you do? You will use the stored energy in battery in night time to fulfill your demands to run any appliances. So that is basically a remove the battery is removing the intermittency of energy in this case of intermittent power sources. So what is intermittent power sources? Intermittent means which are not continuous. Means if you have a power supply in your home from a power grid, you can rely on that. That is intermittent. That is not intermittent, but in case of renewable, let's say windmill or solar cells, these are intermittent in nature, means these are not continuous. It is dependent on the weather as well as your daytime. If it is morning, it is afternoon, or it is night, it is depending on that also. So these are intermittent power sources, and batteries can be used to store and release the energy whenever required. Then we have the next set of questions. The question says, it says a battery is a electrochemical device, energy storage device, energy conversion device, and internal combustion device. So we need to eliminate the
Yes,
options.
sir.
Yes.
सर ये जो स्क्रीन जो है वो नहीं आ रहा है सर,
स्क्रीन नहीं दिख रहा है.
कुछ मतलब 5 ही आ रहा, अभी आया सर। ये चीज बार बार हो रहा है
Okay, let me
मेरे
reshare.
सिस्टम में।
Let me stop sharing and reshare the screen.
ओके सर, थैंक यू सर।
Is it fine now?
Yes, sir.
यस सर।
Okay. So thanks for letting me know. So we are at this question. A battery is which kind of device? So let's eliminate the options one by one. So internal combustion device. So we know battery is clearly not an internal combustion device. Internal combustion device is basically where your combustion of a source or of a fuel is happening to produce energy. Let's say your motorbike engines, or a car engines. So these are internal combustion engines. So our battery is clearly not the internal combustion device. Then energy conversion device. So energy conversion means you are converting energy in one form to another. So let's say you are converting your solar energy to electrical energy in case of solar cells. So that is a energy conversion device, but our battery is not an energy conversion device because we provide electricity energy in form of electricity, and we get energy in form of electricity back from the battery. So we are not converting, we are just storing, and as well as whenever we are required, we are getting same type of energy from that. So it is a energy storage device. Then it is electrochemical device. Yes, electrochemical means it is a term which is made up of electro and chemical. So batteries is a device where chemical reactions are happening, and as well as there some electron transfer or uh, electron transfer reactions are also occurring at the same time. So we call this kind of reactions as electrochemical reaction. Means there's not only the chemical reaction, but the transfer of electrons is also there. So which is also dominated, which is also an important part of a battery, because if we have just chemical reactions, we will not get the flow of electrons in that. So here we are getting electro plus chemical, hence we say it a electrochemical. So batteries are electrochemical device. So option 1 and 2 are correct, and 3 or 4 are not correct for this question. Then we have the second question. It says most metals can undergo oxidation. So this statement is true. We also know what is oxidation. So from our previous question, oxidation means your oxidation state is increasing with emitting an electron. So let's say that you have M, or let's say you have lithium, then it is going in lithium plus with an excess electron. So that is called oxidation. So from the very first definition of a metal from your primary or your school days, so electrons is metal is basically which can undergo oxidation, and which have good electronic conductivity because they have free electrons in them. So this is the first ever definition of metals. And also see, if you see in your electrochemical series, most of the metals goes on the upper side of hydrogen, of this hydrogen level. So most of the metals are here, so they can easily go oxidation, go undergo oxidation. And if you see Ag and different other type of metals, so these are very less to prone to go in oxidation, undergo oxidation. So these are quite stable. So that is why they are used in ornaments. Let's say your silver, your gold, platinum. So they are very hard to get oxidized. So that is why they are very stable in nature. So be it be humidity, be it be exposure to water or any kind of gases. So their oxidations are very limited or very hard to oxidize them. So that is why we use them as ornaments and take them as a stable metals. But if you see this kind of metals, they are very highly prone to oxidation. Then we have the third question. It says, when electrons in a battery moves through the internal circuit in an unhindered manner, then the open circuit voltage is increased, external short circuit is observed, internal short circuit is observed, zero voltage in the battery is observed. So let us imagine the condition. So this is your battery, this is your load, the external load, cathode, anode, separator, and there the question is saying that when your flow of electron is unhindered, or it is very easily the electrons can pass through the internal circuit. This is the internal circuit and the load is in the external circuit. So if the electron can move in the internal circuits, then what will happen? So clearly we have already discussed that if the electrons are allowed, first the first thing is they will not be allowed in any case for any batteries. But if we take this case and if we allow the electrons to move from one cathode to anode or anode cathode, then the condition of short circuit will occur and we will not get any voltage at the load. So the option one is open circuit voltage is increased. So that is clearly incorrect because we will not get any open circuit voltage if all the electrons can move directly from cathode to anode through electrolyte. Then we will get V is equal to 0, or OCV, or open circuit voltage, is equal to 0. Then external short circuit is observed. So not external short circuit. External short circuit is when we don't have any load and we directly touch your anode to cathode. So that is the condition of external short circuit. But here we have the load. So it is incorrect. Internal short circuit is observed. So yes, that is correct. The internal short circuit will happen and zero voltage of the battery is observed. So we will also see the OCB will 0. So option 1 and 2 are incorrect, but 3, 4 are correct. Then we move to our fourth question. So this is a question on batteries again. Let us read the statement. What happens when electron in a battery move through the external circuit that has a finite resistance? So, okay, we have a battery, we have an external load, and electrons are moving through the load, which have some resistance R. So the option one is battery voltage decreases. So battery voltage here means the OCV or the open circuit voltage of the battery. So we know if this is the condition of OCV or the open circuit voltage when your external resistance is, so when you have not connected any load, so you will get the maximum voltage, and that is your OCV or open circuit voltage. So for let's take this example, you have some internal resistance and V in or your voltage is 1.5, as you will get the V out is equal to 1.5 for the open circuit voltage condition. But if you have some load, then your OCV will your voltage will decrease from your OCV, and depending on the load, depending on the resistance value, you will get your V out. So it is a very simple equation. You can find out if your load is, let's say, 8 ohm and your volt V in was 1.5 volt. So from the simple V is equal to IR reaction equation, you will get what will be your V out. So here you will get the V out of 1.33. It is also can also be solved by the Kirchhoff law. And if you know what is Kirchhoff law, you can solve these kind of questions if they ask. So first option is yes, the battery voltage will decrease from the OCV. Second is external short circuit occurs. So no, external short circuit will not occur. If you have some finite resistance, it will only occur in case of you don't have any resistance and you directly connect your cathode to anode. Then option 3, internal short circuit will occur. So no, internal short circuit will not occur because you don't have any kind of flow of electrons throughout the electrolyte. Then the fourth option is battery voltage increases. So that is also incorrect because battery voltage cannot increase from OCV. It will be either OCV or less than OCV. So if you have some resistance, it will be less than OCV. Then we have the fifth question. We need to match these following columns. So first is thermodynamics, kinetics, electrode, and electrolyte. Then we have good ionic conductivity, how fast the reaction occurs. Poor ionic conductivity is good electronic conductivity, and ability to the reaction to happen.
सर
Yes.
सर अभी तक थर्ड क्वेश्चन ही शो कर रहा
Oh,
No, sir,
is
it is
slow?
showing.
है स्क्रीन पे.
Okay, it is. So for someone, it is
Maybe
showing
your
is
internet problem,
your
but
internet
it is
connection
showing, sir.
might be slow. Okay, so you check your internet connection. It might be slow because
हो रहा है सर.
I'm also watching in the second screen, so it is showing the proper PPT, yes, proper slide. So please check,
Yes, sir.
or if you
Proper
have
slide, sir.
still have some issues, you can just try to rejoin. Just leave and join again.
Okay, sir.
Okay. So then we have good ionic conductivity. So we know that your electrolytes should be with good ionic conductivity and very less electronic conductivity. So the option D is with your first option with good ionic conductivity. Then how fast the reaction occurs? So fast means fast or slow is depending on the kinetics. So kinetics term is itself is about how fast or slow is your reaction occurring. So if your kinetics are very fast, means your reaction is very fast. When your kinetics are slow, means your reaction is slow in nature. Then poor ionic conductivity. So we don't have any option for that. Good electronic conductivity. So your electrodes, yes. So your electrode should be very high in electronic conductivity. Means if you have this battery, so in electrolyte, your ionic conductivity should be high, and your electrodes, your electronic conductivity should be high because your electron flow will be from one electrode to another electrode. So be it be charging or discharging, your electronic conductivity should be very high for the electrodes. Then the last option, ability to reaction to happen. So it depends on the thermodynamics. And so if your thermodynamics allows, your reactions will happen. And if they do not allow a reaction, then the reaction will not happen. So accordingly, your option second is correct. Means A will go to fifth, B will go to second, C will go to fourth, and D will go to first. So your option 2 is correct here.
Sir, one thing.
Yes.
Thermodynamics, please. Once clear the
So
concept of
thermodynamics thermodynamics is in that case, basically you have three laws of thermodynamics, even fourth law, but three basic laws. So it shows your what will be your entropy after a reaction, what will be your enthalpy after a reaction, what will be net energy after a reaction. So let's say your electrochemical series, it is itself a part of thermodynamic. So thermodynamics means the thermo is you can take with the temperature, and dynamics mean the change in that. So thermodynamics means you have different parameters. Let's take temperature, heat, pressure, volume. So if a reaction is possible or allowed with the thermodynamics, then only the reaction can happen. So let's say you are making let's say you are making A plus B is equal to C. So you have some product and some energy. So if your A plus B have some energy and your product C will have some energy, then plus some extra energy. Means your energy should be balanced. So if they they are allowed thermodynamically to undergo the reaction, then only they will go to the reaction. Then only the product will produce. Otherwise, they will not produce the product. So thermodynamics itself is a very broad domain or very large subject. So you can just check your thermodynamics and it will show your reaction will occur or not. So in case of batteries also, so if your lithium, let's say plus oxidation, it will emit an electron at this voltage. So we know that the thermodynamics allows that because we know this value. If the value is positive 3.5, then we know, okay, this will not happen. Like in Ag to Ag plus, this value is very high. So we know that it will not go the oxidation. So it is also thermodynamic explanation, thermodynamic rule of that. So if the oxidation is happening, means the reaction is happening. If the reaction is not possible, means it is not allowed. Okay, so thermodynamics itself is a very broad topic. Means if you go itself in the physics domain also, it is very broad and very large to understand. So it is clear. Is it clear to you?
Yes, sir. Thank you.
Okay. So then we have the sixth question. So it says the corrosion reaction and battery reaction are different from each because activation barriers need to be increased in corrosion reaction. So that is true for both because there is one. Okay, let us read the statements first. Increased in corrosion reaction, decreased in corrosion reaction, decreased in battery reaction, and increased in battery reaction. So what is the corrosion reaction? So basically in corrosion, if you take the iron, so it is somehow the reactions are chemical reactions are similar here. There is some charge change, the transfer of electrons here. So let's say you have water. In presence of water, your iron will work as anode and your oxygen or your this area, this gas will work as cathode. And in presence of H2O, their electrons will be transferred and you will in product you will get Fe from Fe to Fe2 plus. So from Fe to you will get a Fe2O3 product. So this is basically your rust. So your rust is iron oxide. So you will get Fe here and Fe will react with your Fe2 plus, sorry, Fe2 plus will react with the atmosphere oxygen and you will get a Fe2O3. So for that, a particular energy barrier is required. So what is energy barrier? So energy barrier is also, it is related to your thermodynamic parameters. So let's say you have some uh, reactants A and you have this is your energy. So at first you have at this place or your energy is low. So whatever reaction you have or whatever you see, everything tries to go in the least possible energy levels. So let's say you have a reactant with this energy level, and if you increase the energy, so they need to overcome some barrier, and they will make product B. So the B is again lower than this barrier, but still higher than this A. So you will again get a equilibrium position or a low energy position. So this will become stable again. So if your a barrier is so high, means your thermodynamics don't allow you to reach to A to B because you need a lot of energy from getting from to overcome this barrier. And if barrier is low, then you can easily go from A to B. So this is the energy barrier which is need to be required for the reaction to happen. So our statement was corrosion reaction and battery reaction different from each other because activation barriers need to be increased for the corrosion reactions. So we need these to be increased very high because we don't want your A to go from B or your Fe to go from Fe to Fe2O3. But in case of our batteries, we want our reactions to be very quick or these energy barriers to be very low. So your lithium should go to lithium plus and lithium plus to go back to lithium. So this should be decreased in the case of batteries. So increase in the corrosion reaction and will be correct, but the decrease in corrosion reaction will not be correct. Then in the case of batteries, decrease will be correct and increase will not be correct. So corrosion and batteries reaction, these are kind of opposite in nature because in corrosion we want to avoid the reaction, but in batteries we want to conduct the reaction. So these are opposite in that way. And their mechanisms are somehow similar to each other because both are going in oxidation reduction processes in presence of some liquid electrolytes. So the activation barrier, these kind of things are well taught in the thermodynamics. How a reaction happens, what will be the products, and the process will be allowed or not. Then we are at the seventh question. It says prismatic cells are better
Excuse
than
me,
other
sir.
types.
Sir, one query,
Yes,
sir.
yes.
Sir, corrosion reaction and battery reaction both are different. Definitely.
Different means we're just taking the one perspective of electrochemical reactions. So here also you are getting from lithium to lithium plus some oxidation here, some reduction in the opposite way. And here also we are getting from Fe to Fe2 plus. So in that way, it is also electrochemical reaction. And battery is also electrochemical reaction. But in case of batteries, we don't want we want the corrosion reaction to occur. So that is why sometimes when we report the batteries, we also show the corrosion reaction and we show that the corrosion reactions are very low in the batteries. That is why our batteries are good. So in our case also, in our lab, we have reported that, okay, the corrosion reactions are very slow for our electrodes, means your electrodes are safe and the lives are very high for the electrodes. So the electrochemistry is similar, just the things are you have OH minus ions here, you have some different type of electrolyte, you have the air is present here as a one electrode. So the reactions are similar but in opposite way. So one example is also you will see if you read the metal air batteries. So what is a metal air battery? So in that case, your one electrode is your metal. Let's say whatever metal, aluminum or whatever metal you have, and the another electrode is air only. So how will you get the air? So this is basically open to air, and one terminal is in connected to your electrode, whatever cathode you have, whatever electrode you have, and one terminal is open to air. And you have some in presence of electrolyte. So that is also very much similar to this kind of corrosion reaction. So that is called the metal air battery. So that is why I am saying that these two reactions are quite similar, but just our perspective is just to increase this energy barrier in the corrosion reaction and decrease in the batteries. Okay. Then we see the different types of cells. So prismatic cells are better than other types of cells because when they are arranged in parallel series, significant extra gap remains between the cells to accommodate swelling. They can be arranged in parallel series without gaps. These are better suited for use in mobile application due to space constraint. These are softer in comparison to other cells. So First, we need to see what is difference between this. This is first the coin cell. Coin cell is basically, you also know is these as button cells. So these are the shape of buttons. So basically you have flat cathodes, flat anodes, then you have a gasket, then you have a coin cell case, and these are all crammed into a cell. So this is the coin cell. Your cylindrical cell is basically, it is a shape of a cylinder, and your cathode, anode, and separators, these are rolled in a circular manner. So these are rolled inside the circular, inside the cylindrical casing. In a pouch cell, you have a sheet of, or the rectangular sheet of anode, cathode, so and separator, and they are sealed in a pouch. So it can be of multiple layers, and you can have multiple layers in a single pouch cell. Then this is your prismatic cell. Prismatic cell means again you have a closed packing. So you have filled electrolyte, then separator, cathode, separator, and anode, multiple layers of separators and cathode anode. So it is a kind of a dense. So you can see here, basically you have a aluminum shell outside, then multiple layers of cathode anode. So multiple batteries, then it is sealed in a aluminum shell. So advantages is you have very minimal gaps. So these are very highly dense. So very minimal gap. So they can be used where need you have a space constraint. So you can use them, but they are not softer in comparison to other cells, and they don't have between the cells. You don't have extra gap to accommodate swelling. So it doesn't have any space. So option 1 and 4 is not correct, but 2 and 3 are correct. So this is basically different type of battery configurations. Then we have the statement, the question 8. The statement is plating stripping mechanism is observed in lithium metal based batteries. So we have two assumptions. So it can lead to the battery explosion due to short circuit. And we have the second is this mechanism leads to dendrite formation in the battery. So what is a plating stripping mechanism? So this is basically term used in a lithium metal batteries. Means your lithium is present as a single metal sheet. So this is your lithium, and this is your SEI layer. SEI layer is basically solid electrolyte interface. So this is your lithium metal is in form of solid. Then you have some liquid electrolyte. So this interface is called solid electrolyte interface, or SEI layer. So what will happen? So when your lithium will go from anode to cathode. So basically in form of lithium ions. So it will move apart from this lithium foil through the electrolyte. So it is called the stripping. Then in the opposite, so let's say in charging, in discharging, let me in the process of discharging, your lithium will go from lithium metal to your cathode, from anode to cathode. So the stripping will happen. But what will happen in the reverse reaction? When charging, your lithium will come back to your lithium foil. So what is this is called stripping, and this is called plating. Plating means coming back to the lithium foil or the metal foil. But what is the issue we see? So what will happen when the, let's say, lithium is going from here? So it will make a channel here. So when your reactions are quite fast, so this channel, what will happen? Your remaining lithium, whatever returning lithium ions, they will just accommodate at this channel. And let's say this is accommodating here, then the next will come and sit on that particular void. So by that the lithium metal will make a structure, dendrite like structure. Dendrite means if you see the shape of a tree, So similarly, it will make a dendrite-like structure and it will grow like this. So from this lithium metal, so it will grow like this. So it is in the direction of cathode. So ultimately, what will happen? Because this is made up of lithium and it is quite conductive in nature. So it will reach throughout the separator. It will reach to cathode. And if it will reach the cathode, it will get a conductive path for the electrons. So your electrons will move from here to here and your short circuit will happen. So it is a major issue in lithium metal batteries. So let's say this is your metal lithium and you have different lithium layers, but your returning lithiums are sitting here. Then the next atom is sitting here because they will find the shortest path here. Then the next will sit here. And now all the returning lithiums are finding the shortest path is here. So by this, you will make a grain-like structure, or it make a dendrite-like structure, grain by grain, and your cathode will touch your anode. So it will cause short circuit, which is very harmful, or which destroy the battery. So it is a very huge drawback of a lithium metal battery. So what is the solution? So different type of anodes are used. So let's say lithium carbon wood. So in that case, you have a lead structures in which lithium is sitting. So let's say this is your lead structure. So what will happen? Lithium will go equally from all while stripping, and when it comes, it will come back to different levels. So it will fill all the levels, and it is not connected with each other. So there is no channel walls. So this channel walls, so there is no contact with lithium metal. So there will be very less dendrite formation in this case. So that is why different type of anodes are used, and graphitic anodes, graphene as anode. So these anodes are used, and you will not see lithium metal batteries in market. You will see only batteries with have either graphitic or graphite as anode, or graphene as anode, or some other structures as anode.
Sir,
So
we
our
place wood parts between lithium
wood
stripping.
is wood means it is wood derived carbon. It is not wood plank or something like that. It is just showing you the illustration. It is just show you. So this is wood derived carbon. See, wood means wood derived carbon. So you just burn the wood and whatever biocarbon you get, so that is the carbon. So different type of carbons are used here. Where carbons can have a lead structure, lead morphology. So this kind of carbons are used, and graphite is used, graphene is used, and different carbon nanotubes are used. So different type of carbons are used with lithium.
Sir, carbon wood is used to isolate.
I'm not showing this is just a representation. Carbon wood means carbon derived from wood. So wood is a source here. So you take wood, this is an organic substance, then you burn it, you will
What is the
get
function of
in form
carbon
of
wood
carbon.
here?
Sorry.
What is the function of carbon wood
Yeah.
in lithium stripping?
So just you are confusing with this wood term. So wood is just showing the which type of carbon is this. So you will get a layered carbon. So it is, you can take as this is a representation. So if you take graphite, so graphite has layered structure. So these parallel lines means you have some layered structure in between your lithium is sitting. So when you charge or discharge during stripping, your lithium will go back from your layers of carbon, and when plating, it will sit again to the layers of your carbon. So I also these are carbon based, so these are conductive. So your anode is conductive enough, but the lithium is not in touch with each other. So you have different levels, kind of levels. So this is your schematic or just a representation, but in real case, what will happen? You have a highly porous either carbon or highly porous anode where your lithium can sit. So it will it will decrease your chances of this dendrite formation. So that is why these kind of structures are used. And this is a very huge problem in lithium-ion batteries, which is uh, terminated by the use of any kind of carbon or graphite or graphene or this kind of different carbon structures. Okay, so this is basically carbon-based electrode, not wood. Wood means wood-derived carbon. Okay, is it clear?
Yes, sir. Thank you.
So the statement one is right. Like it can lead to battery explosion due to short circuit. So because if your dendrite is reaching to your another electrode, so a lot of heat will, so your electron will transfer directly, and the reaction will be very fast, and lot of heat will emit. So it can cause to explosion of the battery. So the option one is correct. The second is these mechanisms lead to dendrite formation. So that is also correct. Means your option one is right. Two is right. Uh, Third option is not correct because only second will is not right, and both are wrong is also not correct. So option one and two are correct in this case. Then we have the ninth question. It says at higher C rate, capacity and lower C rate, capacity of the battery can be exerted. So we have already discussed. So at your C rate will be, if your C rate will be higher, your capacities are lower. And if your C rates are lower, your capacities are higher. So it is, I also mentioned the reason. If you have low C rate, you will give your battery sufficient time, because in batteries your lithium ions are moving from one anode to another, one electrode to another electrode, so it takes some time. So if you give sufficient time, so your lithium ions will easily go and efficiently will intercalate in your cathode, and if you're coming back, they can easily come back and sit at their positions, at their respective position. So if you give sufficient time, then your capacities will be higher. If you perform this reaction very high, so what will happen? It will not efficiently perform the reaction, and your capacity will be lower, as well as your life cycle cycle life will also be affected. It will also get lower. So the option two is correct. At higher C rates, lower capacities are found, and at lower C rate, higher capacities are achieved for a battery.
So C rate means charging rate.
Yeah, C rate, I also, we did this question. If you see that, C rate means, C rate is basically charging rate. So 1C means you're charging a battery in 1 hour. 2C means you're charging faster with twice faster rate. So 2C means 1/2 hour means 30 minutes. So as you go higher C means faster charging rate, and if you're going slower C means C/2 means the half time. Sorry, double time in half rate means it is C/2. So basically 1C is equal to 1 hour of charging. Then if you go higher C's means faster, and slower, smaller C's means the slower. So 1C is your 1 hour. So higher C means your capacity will be lower. Then we have the 10th question. It is saying that as the current drawn from a cell in steady, if a current, sorry, as the current drawn from a cell is steadily increased. So this is your basically a cell or battery which is having a VOC is V naught. You have flowing of some current, and you have some resistance or load here. So if your voltage, if your current is continuously drawn, your voltage will decrease, because you know there will be, you have only VOC. If you increase the resistance, your voltage will decrease by the time, and you need to recharge the battery. So you will get this kind of curve with a steady current rate. Also, your voltage will decrease if you have some load. If you don't have any load, so you will get your maximum voltage, which is VOC, and you increase the resistance, your voltage will decrease by the time. So the option third is correct here. Then we have the questions from your previous week discussion. So we have 10 questions from the last week. So it is 8:10. So let us take a break of 10 minutes. Then we will discuss these previous week questions. So we will be back at 8:20.
Okay, sir.
Okay, so we are back to our discussion. So these are the questions from last week. So we have 10th question, 10 questions. So let us start with the question one. So it says water turbulence in ocean is what? So we have in the OTS type of energy storage systems, we have seen the different type of movements in the ocean. So this image also shows the different type of circulation. So this is the Langmuir circulation, the shear instability, convection, then the cooling and heating at the surface of the ocean. So we know that the as you go deep in the sea surface in the sea, you will see your turbulence will decrease. So options are increases with depth. So that is incorrect because we know the turbulence is these turbulence are due to the wind and the cooling and heating. So as you go deep, your circulation will be your turbulence will be very low. So the option one is incorrect. Then it is independent of depth. So that is also incorrect because we know it is dependent to depth because at different level of depth, your circulation will change. Then the option third is decrease significantly beyond a certain minimum depth. So that is true because after a depth of let's say a few meters, your turbulence will be significantly decreased because the effect of the surface phenomena, be it be wind or be it be cooling or heating due to sun, it will be very minimized. And we have also seen that your temperatures are also quite constant after a particular depth. So that's the option third is correct. Then the option fourth is completely absent at any depth. So that is clearly incorrect because we know that at any depth it cannot be completely absent. So you have some kind of circulation, then some kind of turbulence. So the option one, two, and fourth are incorrect. Then the third one is correct. Then we have the question two. Just let me. So the question two is an astronaut and a sea diver were discussing about the challenges in their field and finally come to a conclusion that their respect to dealing with different pressure, stopping in a submarine at a maximum depth of an ocean blank is challenging than as being inside the spaceship at the moon. So it is just comparing a sea diver to a astronaut. So we know that the pressures are very high, even few kilometers away from the surface inside the sea. So it is very much more challenging for a sea diver to go beyond, let's say, 2-3 kilometers. And you see, this is another example is so many people have gone to the moon, which is quite far away from this Earth's surface. But let's say 12 to 15 people have gone, but only 2 to 3 people have divers have gone to few kilometers. So it is a very significant number because at few point, let's say which is the Mariana Trench is the deepest one, which is very I don't remember exactly, but it is around few kilometers away from the seabed, sea surface. So very few people have seen these after what is there after 2 or 3 kilometers, and compared to this distance, the many astronomers they have gone to much far depth, far height. So the statement is just a comparison of, and it is just an example of that a lot of things are need to be investigated in the under the sea after this kilometer range. So they will be more challenging than a spaceship in a moon because we need to take care of very high temperature, very high pressures in the inside the sea. Then we have the question third. So we need to match the different columns. So we have already discussed this type of energy storage or energy generation systems. The OTEC we have discussed, the photovoltaic or photocatalysis we have discussed, geothermal and wind energy also we have discussed. So we need to match the columns. So we know that impacted by time of the day. So among all four, the photo PV, the photovoltaic or photocatalysis are highly impacted by the time of the day, because in this daytime you will get peak power due to the presence of sun, but at the night you will have the zero or near zero power. So it is the option one is correspond to the column the B from column one. Then second one is can support air conditioning in coastal areas. So we have seen and we have discussed that OTEC, from the OTEC we can use that cold water or the low temperature water to support the air conditioning in the coastal areas. So this we have seen in the previous classes. Then atmospheric convection due to the solar energy. So we have seen the system. I also explained how this the wind streams are generated. So we have seen that due to the convection of the atmospheric convection due to the solar energy. So we how the wind currents are generated. So we have discussed this in previous classes. So it is related to wind energy. Then we have seen the what is the can affect marine life. So we know that OTC is related to marine life only in among all four. So OT is related to that. Then trapped gases are released. So trapped gases are basically in the geothermal energy, because in this energy is achieved from the high temperatures from beneath of the earth surface. So if we have any trapped gases in that case, so option 4 fifth is related to C. So your option first and option fourth will be correct, and second and third will be incorrect in that case. So it is just to match the column 1 to column 2. Then we have the question 4. It says arrange the following in the right order for the functioning of OTEC plant to generate electricity. So again, this schematic is the representation of OTEC plant. So we have a warm water surface here, which is having temperatures of 25 to 35 degrees. Then we have low temperatures of 3 to 7 degrees in the cold water, cold deep water. Then we have a condenser connected to cold deep water and the evaporator with the warm surface. Then we use a turbine to generate electricity, and some water will be used as fresh water as well as for the air conditioning. So the first step, what is the first step? So among all this, I'm just saying that first step is using this temperature difference. So the first step will be here. So pulling out water from the surface from 30 and from the, let's say from 1 kilometer to 20 degrees Celsius. So this is your first step. So you will have a temperature difference. Then the second step is sending the water in the low pressure chamber. Then your water will evaporate at evaporator. This is the third step. Then evaporated water will go in the turbine. It will rotate the turbine blades. And for this is the fourth step. Then it will produce some electricity. Then it will go to the condenser. This is the fifth stage. And then it will back to the drain in the sea. So from one first step to a whole cycle will be something like that. So this is your fully functioning of OTEC type system, and your option second, your option 2 will be correct in that case. Then we have the fifth question again on the OTEC type of system. So it says, though OTEC technologies and geothermal energy taps the stored energy to run the turbine for generating electricity, but the two technologies differ from each other because, so we need to see what are the differences. OTEC does not involve heating water to generate electricity. So yes, that is correct, because OTEC works on the difference of temperature at different depth of water in sea. So it doesn't involve the heating of water, but in the geothermal, you have high temperatures beneath the Earth's surface. So if you have any fluid, let's say water, so it will be heated. It may be converted in the form of steam in case of geothermal energy. So that is the option is correct. The second option is the direction of temperature gradient is opposite in two technologies. So yes, in geothermal, we have the high temperatures at at the depth, we have the high temperatures, and at the surface, we have the low temperatures. Let's say you have more than 100 degrees Celsius below the Earth's surface. And at the Earth's surface, you have the room temperature, or let's say around 20 degrees Celsius at the surface. But in OTC system, as you go in depth, your temperature will decrease. So your direction is opposite. And at the surface, you have the higher temperatures. So in both of the cases, you have the opposite temperatures, temperature technologies. So these are basically the temperature gradient is opposite in both of the technologies. So option 2 is correct. Then third one is one uses naturally stored energy to heat the water and other uses a process to evaporate the water. So yes, that is correct, because in the OTEC, you use the stored energy in terms of heat, because one is at high temperature and another one is lower temperature. And in geothermal, the evaporation of water is used, where you get the steam after the evaporation of water. Then the fourth option is temperature of water is nearly constant past a certain depth, whereas the temperature keeps increasing in the depth of water. So that is also correct. Depth, the temperature will be constant for OTEC, or for a set particular depth in a sea. But in geothermal, as you go deep and deep, your temperatures will increase. So basically, these four options are correct, and we have compared the OTEC with geothermal energy. Then we have the sixth question. It says two thermal energies plants are commissioned at two different locations. One is near to fault area, and one is at the perfectly undisrupted location. So first plant will show the higher efficiency than the second plant. So we have discussed in our geothermal chapter that your geothermal energy is basically where your geothermal activities are very high. So where activities will be high, where you have different type of faults. So faults are basically present in between the tectonic plates. So if you have different type of faults, let's say normal, reverse, or strike up. So these are different type of faults. So the geothermal activities are very high here due to the friction between the tectonic plates. So your activities will be higher, your geothermal energy will be higher. So if you need to choose a location, the location with the faults are much preferred compared to your undisrupted locations. So this statement is true that yes, you need a location near to fault area. Then the next question is on the evaporation and the boiling point of water. So super saturated steam can be obtained by what? So we have seen that we have discussed where you use super saturated steam. So here we are just comparing just normal evaporation with boiling. So let us take the question options. So first is the heating of the water. So that is correct. We need to first heat the water to make the steam. Cooling the water below 0 degrees Celsius, that is incorrect, because we'll just freeze the water. Then reducing the pressure. So yes, that is also there. Increasing the pressure above 1 atm. So we have seen basically what is the evaporation. Evaporation is if you have any liquid, you have some particle or some molecules of a liquid just near to the surface of the liquid. So let us say this is a water. So you will always have the vapors. Vapor is the molecules of same material, same liquid of So these vapors is basically the molecules of air or in the gaseous form, the molecules of water. So at the place, at the time where you are increasing the temperature, so you will increase the temperature, so the vapor pressure will increase, means more molecules will go from liquid phase to gaseous phase. So there will be a vapor pressure. So at some time, your vapor pressure will be equal to 1 atm or your atmospheric pressure. So at that pressure, at the temperature, you cannot heat more and you cannot evaporate your water more at that point, more after that point. So what will happen? At that case, your water will start bubbling. Bubbling means your liquid temperature and your vapor temperature is comparative. So your water will show disruption, high disruption, that is equal to your bubbling. And you see in case of 100, in case of water, you will see at the 100 degrees temperature. So what is the option to increase the temperature of the steam? So you just evaporate or you just decrease the atmosphere, this pressure. So if you decrease the pressure, your your vapors will be, or your boiling point will achieve faster. So you will get a super saturated steam in that case. So you need to basically reduce the pressure to get the super saturated steam. Then we have the ninth question. What kind of materials coatings are used for coating turbine blades? So this question we have already taken. So we know that we need the ceramic coatings which have good thermal barrier for that blades of the turbine, and we don't need composite or metallic coating because it is already made up of any kind of alloys. So either alloy or if you have the ceramic is an option, ceramic is correct, then thermal barrier in the coating. Then the next question is on the OTC plant again. So what are the challenges with OTC plant? So first is pressure, depth, water current, and direction of surface water currents. So depth pressure is certainly a challenge because you are working at the depth of few kilometers. So your pressure will be very high, your depth will be very high. So yes, and your water currents are also high. So you need to take care of these three parameters. But direction of surface water currents. So this is your surface and this direction of surface water current will not affect because you are already at certain depth in the sea. Sorry, option 1, 2, and 3 are correct, but option 4 is not correct. So we have done these questions. So we have still have 20 minutes for our interaction session. So if you have any kind of questions, any kind of queries, you can just raise your voice and just let me know. So this was our 10th week discussion on this course, and we covered the batteries, lithium-ion batteries, different type of batteries, and few previous questions. So if you have any kind of doubts in that, and one more announcement is also there that I will be taking an extra lecture or extra session after your 12th week. So the course is for 12 weeks, but I will take an extra lecture on Wednesday of the 12th week. So whenever we have, sorry, Thursday on this 12th week. So whenever we have the last class on Tuesday, on Thursday, we have an extra session. So where we will be discussing the whole syllabus and whatever your queries are, because your exam will be after that. So whatever the queries are, we will be discussing. So if you have any kind of questions or anything, so you can attend that on Thursday of the last week. So anyone of you, if have any kind of questions, you can just ask me out here. Else you are free to leave. You may leave if you like. And I am here till 9.
Sir, can you repeat question number 3? I have missed
Question number
3.
3. 3 of which? This one?
Yeah, this one.
Okay, this is basically the question is when electrons in a battery moves through the internal circuit is in an unhindered manner, then what will happen? So basically, if you have a battery, you have cathode and anode as electrode, you have electrolyte in between and a separator. So the use of separator is it will not allow the cathode and anode to get in contact directly. So it should not short circuited. So the purpose of the electrolyte is electrode is to keep them separate, and the purpose of electrolyte is to move the ions from one side to another side, because we want the flow of lithium ions from one side to another side. So your electrolyte will allow the flow of electrolyte, but not the flow of electrons, because your electron should flow in the outer circuit, external circuit. So if you allow the, in this case, in the question is given that if you allow the flow of electrons directly, so what will happen? You will get the condition of short circuit. So instead of external circulation, you will directly short circuit your battery. So which is not preferred in any batteries, and which is avoided by the separator and the electrolyte. So our options are open circuit voltage is increased. So it will not clearly not increase, because if you short circuit a battery, you will not get any OCV, or your V will be, or your open circuit voltage will be 0. Then the external short circuit is observed. So that is also incorrect, because you will not get external short circuit. External short circuit you will get in case of when you don't have any load and you just directly connect your cathode to anode. So this option is also incorrect. Then the third is internal short circuit is observed. So that is correct, because in the direct flow of electrons, you will get an internal short circuit. Then zero voltage is weight is observed. That is also correct. So basically your option 3 and 4 will be correct, and remaining are incorrect.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Thank you for attending the session.
सर फोर्थ वन रिपीट कर दीजिए ना फिर से
Answer? Which question?
फोर्थ को
Fourth. This one.
जी सर
Okay. So basically, this is on the same previous fourth question based on that. So what happens when your electron in the battery moves through the external circuit and has a finite resistance? So this is basically the standard condition when your electrons are moving through the external load. Load is basically some resistance or any equipment you use. So if you don't connect your external circuit, means which is in the condition of open circuit, so you get the maximum voltage. So that is called the open circuit voltage, where no load is connected. Then you, let's say, take some load, so your voltage will drop according to the load. So if you have seen any questions in electronics, so if you have seen the Kirchhoff's law to solve this kind of circuits, so you can calculate simply what will be your V out if you have some R resistance here. So this is just to demonstrate. Otherwise, if we see the options, so battery voltage will decrease. So yes, your battery voltage will decrease. If you increase your resistance, your battery voltage will decrease. And what will be your highest voltage? That will be OCV, open circuit voltage, in when no resistance is connected, when circuit is open. So option 1 is correct. Second is option 2 is external short circuit occurs. So it will not occur if you have some resistance. It will occur only when you directly connect your terminals or your cathode to anode. Then the third is internal short circuit occurs. So it will not occur because there is no flow of electron intrinsically. So it's also not correct. Then the battery voltage increases. So it is not that because battery voltage will not increase above OCV. It will only decrease when you connect your load. So option 1 is correct. All remainings are incorrect.
Yes, sir. Thank you, sir.
Okay.
Sir, can you repeat the question number 7 and 8?
Which question?
Question number 7 and 8. So,
This one and this one, right?
yes, sir. Yes, sir.
So seventh is basically different type of batteries. So we have seen this coin cell type, cylindrical, pouch cell, prismatic cell. So coin is basically what you see in button cells. Cylindrical cell is basically in cylindrical shape, and the cathode anodes all are rolled inside the cylindrical shell. Then pouch cell is basically you have some rectangular pouch shape cathode anode with it can be of multiple layers. And your prismatic cell is you have a outer shell, let's say metal shell of let's say aluminum. Then you have densely packed cathode anode and separators in a row. So the option 1 is it has significantly extra gap remains between the cells to accommodate swelling. So that is not correct because they are very closely packed. And so second option is they can be arranged in a parallel to series without gap. So yes, that is correct because that can be packed in different configuration in series or parallel with closely packed, and they are suitable for mobile application due to space constraint. So we have seen that there's very highly packed, so space constraint also used. And these are softer in comparison to other cells. That is incorrect because these are not softer, but these have this own configuration. So option 2 and 3 are correct here. Then the eighth one is basically we have two statement on plating and stripping. So plating and stripping means plating is basically stripping is basically your lithium ion is going out of your lithium metal layer. So this is your lithium metal and your lithium ions are going. Plating means coming back to the lithium plate. So you see your dendrite formation happens when you have a let's say you have a void here and your lithium ions will accommodate on their void one by one and they will make a dendrite like structure. So this is let's say this is you make a dendrite like structure. So they will come in contact and the battery will short circuit and it can make a explosion. So your option 1 is correct. Your assertion 1 is correct that it can make a explosion. Their assertion 2 is may lead to dendrite formation. So that is also correct. So option 1 and option 2 these are correct. And option 3 is saying only the assertion second is right, and option 4 is which is saying only assertion both are wrong. So these option 3 and 4 are not correct, and first and second are correct.
thank you, sir. Thank you, sir.
Sir, please repeat question number 5. 1 to 5.
1 to 5. So I suggest you that we have a limited time. So this video is available on YouTube. Okay. So you can go directly. So your link will be provided. You see, so you can check these questions and you can repeat the video.
Sir, can you explain the theory about the 10th question? The
Theory of-
current,
Theory of 10th question.
10 is the
Which
current
part?
drawn from the current.
So this is basically your discharging of a battery. Okay, so
Sure.
if you have, so in basically what is happening, your lithium is going in lithium plus and your lithium plus is going back in lithium. So by the time when you discharge, let's say your mobile batteries, so its voltage decreases. Its current may be fixed, but its voltage decreases with time. So basically you connect to resistance and you get your, let's say if your voltage is from 4 to it will decrease to 3.5. So this is a typical discharging of a battery. So it is also saying that as the current drawn from the cell is steadily increased, the voltage will what? So first increase, then decrease, first decrease, then increase, then keep increasing. So both options are incorrect and it cannot keep increasing. So it is basically keep decreasing. So your voltage gets decreasing.
Okay, sir. Thank you. Thank you so much.